We're going to be looking at coordinate geometry, but using the rules this time rather than just looking at the graph. So if I've got 2 points, A and B, A is -1, -3, and B is 2, 3. If I wanted to find the length of the interval AB, I need my rule, my distance formula, which is x2 minus x1 all squared plus y2 minus y1 all squared, which comes from, and square root all that, which comes from Pythagoras' theorem. Now, I need an x2 and an x1 and a y2 and a y1. I might call this first point x1, y1, and this second point x2, y2. Doesn't matter, I could have chosen them the other way around, it will still work out quite nicely. Now, if I have x2 take away x1 squared and y2 take away y1 squared under the square root sign, I could just put all that in my calculator, but doing it step by step, this becomes 3 squared, this becomes 6 squared, so I end up with 9 plus 36, which is the square root of 45. That is the exact answer, and if I wanted it to a decimal place, I could just put it in my calculator, which would be 6.7 to 1 decimal place. I could also find the midpoint on the interval AB by using the midpoint formula, which is x1 plus x2 over 2, and the y-coordinate y1 plus y2 over 2. Then we just make a straight substitution, x1 plus x2 and y1 plus y2 over 2. Working that out, I end up with 1/2 and 0. So the midpoint of the interval joining A and B is 1/2, 0. We can also find the gradient of the line that would join A and B, or the slope. So gradient, slope, same thing. If a line goes up across your page, it's got a positive slope, so one of these have a positive slope, and lines like this have a negative slope that goes down across your page. To find the gradient, we usually use the little letter m. 2 words, rise over run. And rise over run, rise is the y, difference in the y values over the differences in the x values. And from before, we've got our y2 and our y1, being careful with the negatives, and x2 minus x1, which is 6 over 3, which equals 2. So that means if I was to join A and B together, rise over run, the slope would be 2. So for every 2 I went up, I would have to go 1 across. So having a look at that, all that information, if our points are A and B, we've got the length, 6.7 units, we've got the midpoint, 1/2, 0, and we've got the gradient, which is 2. Now, what happens if I wanted to draw that line? Find the equation of that line. The equation of a straight line has the basic form y equals mx plus c, where m is the gradient and c is the y-intercept. Now, we've just found out the gradient, so we can replace the m with 2. So now I know the equation of my line is y equals 2x plus c, but I have to figure out what c is. The way I can do that is by either putting in the point A or B, because they both lie on the line. So I'm going to put the point B in, remembering that the 2 stands for the x and the 3 stands for the y. So instead of having y, I'm going to put 3, and then instead of having the x, I'm going to put 2, and then I've still got my plus c on the end. That becomes an equation. 3 equals 4 plus c, and solving that, c would equal -1. So replacing that in my equation, I'll have y equals 2x minus 1. So that's the equation of our line that joins A and B. So having a look at that on a number plane, I've put on my point A and my point B and drawn a line between them. So if I was to look at the length of that line That would be 6.7 from before. The midpoint, m, is at half 0. And the gradient of the line was 2. So from A, my rise is that far, which is 6, and my run is that far, which is 3. And 6 over 3 is 2. And we found the slope to be 2. And if we look at the equation of the line, which was y equals 2x minus 1, the minus 1 here is where it cuts the y-axis down here at minus 1. And then the 2 is the slope, or the gradient. Now, another thing we can work out is if we've got our straight line and I want to know whether a particular point lies on that line. Say, for example, I want to know, does the point 5,8 lie on that line? Now, I could draw the line, plot the point 5,8. So we can substitute the 5 for the x, and the 8 is what the y should end up being. So let's have a look. So we've got y equals 2 times, not x anymore, but I'll put in 5, take away 1, so y should equal 10 minus 1, which equals 9. But y doesn't equal 9, it equals 8. So does the point 5,8 lie in the line? No. If we've got lines that are drawn and we want to find the equation of it, we think about the equation y equals mx plus c. C is where it cuts the y-axis. We can see that it cuts the y-axis at 1, so that means I need to have y equals mx plus 1. Then I go to the slope. I've got 2 points. If I have a look at the rise and the run between those 2 points, that's what my m will be. So m equals rise, which is 1, over run, which is 1. So the gradient in this case is 1. So now my equation is y equals 1x plus 1, or if you like, just y equals x plus 1. For the next equation, it's going down across the page. We still start off with y equals mx plus c. This time, it cuts the y-axis at 2. So my equation starts as y equals mx plus 2. Now I have to find the slope, find out what m is. Now, working across the page, the first point I come to is the 2 on the y-axis. Instead of going up across my page, I go down across down the page, 2, and across 4. So even though my gradient looks to be 2 over 4, which is a half, because I'm going down across the page, it's a minus 2. So in this case, my gradient is minus a half. So the equation of this line becomes y equals minus a half x plus 2. I could also just write that as y equals minus x on 2 plus 2.